You know when you're cruising down a perfect stretch of highway, just enjoying the drive. I bet the last thing on your mind is what's holding the whole thing up. But right under that smooth black surface, there's a massive hidden world of engineering. And today, we're going to dig in.
So, let me ask you, what do you think is the most important part of a highway? Is it the asphalt? The painted lines? Maybe the guardrails? Well, that's kind of a trick question, because the real answer is something you will probably never, ever see. That's right, the most crucial part of any road is its foundation. In the world of civil engineering, we call this whole process earthworks. It's this painstaking, totally invisible job of preparing the ground, and it's the real hero behind your smooth daily commute.
All right, so before you can build anything, you've got to prepare the site. This first phase is all about creating a completely clean canvas, a predictable starting point for the massive project that's about to happen.
It starts with something called clearing and grubbing. I know, it sounds kind of rustic, right? But it's the official term for getting rid of everything on the surface. We're talking trees, bushes, big rocks, even digging out all the roots and stumps. And every single hole that's left behind has to be meticulously filled back in and compacted. You can't have any weak spots, not even from the very, very beginning. And it's not just clearing out nature. Oh no. This is a total reset of the land. Any old buildings and their foundations, abandoned pipelines, old bridges, leftover pavement, it all has to go. Even boulders heavier than half a ton get hauled away.
So yeah, all of that clearing, all of that demolition, it's all about creating one thing, a perfectly uniform, stable, and known surface to start from. And with that clean canvas ready, the engineers can finally start shaping the land itself.
This is where the heavy machinery really earns its keep. We're talking about sculpting the landscape. This is the phase where the vertical path of the road, its hills and valleys, is physically built. It is a massive, massive earth-moving operation. And it all boils down to two basic actions: cut and fill. A cut is exactly what it sounds like. You're cutting into high ground to bring the road level down. A fill is the opposite. You're building up low ground to bring the road level up. And here's the genius part. A lot of the time, the good material you dig out from the cuts is saved and reused to build the fills, which are officially called embankments.
But listen, an embankment is not just a big pile of dirt. Not at all. It's a highly engineered structure, built with incredible precision, layer by layer, designed to support millions of tons of traffic for decades without shifting or settling. So how do they actually build one? Well, first, the original ground is scarified. That just means it's roughed up so the new material will bond to it better. And then it's compacted. Then the fill material is brought in and spread out in thin, perfectly even layers, usually just 8 inches at a time. And get this, the moisture level of each layer has to be just right before these giant rollers come in and compact it to a precise density. Only then, and I mean only then, can they add the next layer. This quote from a highway design manual really says it all. The person building the road is 100% responsible for making sure these embankments are stable. I mean, the stability of the entire road rests on this process. Any mistake, any single weak layer, could put the whole project in jeopardy. The pressure is just immense. Okay, so we've cleared the land, we've sculpted the basic shape of the road, now we get to the final, and I'd argue the most critical layer of the earthworks. This is the direct foundation for the pavement, and it's known as the subgrade. The subgrade. It's the top 8 inches of the entire earthwork structure. Think of it as the bedrock for the actual road. It's what directly takes the load from all that traffic, and its strength and stability are what determine how long that beautiful road surface is going to last. And this is not just any old dirt they pull from the side of the road. The subgrade material is like a specific recipe. It has to meet these incredibly strict requirements for strength, for density, for the size of the particles. It's basically a high-performance, lab-verified material. Now, we've said the word compaction a lot, and that's because it is the key to everything. These heavy rollers literally force the soil particles closer together, squeezing out air and water to create this super dense, interlocked mass that won't shift or sink. I mean, you wouldn't build your house on loose, fluffy ground, would you? It's the exact same principle, just on a massive scale. And check this out. The standards get way tougher the closer you get to the surface. Down in the main part of the embankment, they need to reach 90% compaction. As you get to the upper portion, that jumps to 95%. But that final, critical subgrade layer, it has to be a perfect 100% of its maximum density. There is absolutely no room for error.
So how do they make sure they're hitting these perfect numbers? They test, constantly. For every 1,500 square meters of a completed layer, which is about a third of an acre, they have to perform a field density test to prove it meets the standard. So you can see, this whole thing is about intense quality control. Every single layer is tested, every single section is verified, every step of the way to make absolutely sure there are no hidden weaknesses in the road's foundation.
So after all of that incredible effort, what's the payoff? Why does all this hidden, painstaking work actually matter to you when you're just trying to get to work in the morning?
Well, we've just seen the whole journey, right? From clearing a raw patch of land to sculpting its shape, meticulously building it up layer by tiny layer, and finally, perfecting that all-important subgrade foundation.
And here's the bottom line. A road is only as good as the foundation that you can't see. You know? Potholes, cracks, sinking pavement, those are rarely failures of the asphalt on top. More often than not, they are symptoms of a problem that started deep down in the earthworks, maybe years and years earlier.
So really, the next time you find yourself driving on a brand new, smooth highway, just take a second. Remember the incredible, invisible engineering project that's right there under your wheels, the mountains of earth that were moved, the thousands of tests, the layers upon layers of precision, all of it just to make your journey seamless and safe.
It kind of makes you wonder, doesn't it? What other massive, invisible engineering projects are out there, hiding in plain sight, quietly supporting the world we all rely on every single day?